In a redox reaction, one substance is oxidized, so it loses electrons, and one substance is reduced, so it gains electrons. An easy way to remember this is Leo goes Gur. So lose electron oxidation, gain electron reduction.
Oxidation numbers are something to help us keep track of whether a substance is oxidized or reduced during a reaction. A positive or negative whole number is assigned to an element on the basis of the set rules shown here. For an atom in its elemental form, the oxidation number is 0. In a monoatomic atom, the oxidation number is its ionic charge. Nonmetals usually have a negative oxidation numbers. For example, oxygen is almost always -2, with the exception of peroxides. Hydrogen is +1 when bonded to nonmetals, and hydrogen is -1 when bonded to metals. The sum of oxidation numbers in neutral compounds is 0. The sum of the oxidation numbers in a polyatomic ion is the charge of the ion. So here are some examples of oxidation numbers based on the rules that we just looked at. So Cl2 is a free element, so based on what we learned before, its oxidation number is 0. NaCl, these are two ions that are bonded together, but their overall charge is 0. So we know that this is +1 and -1. Now going on to carbon dioxide, we know that oxygen's oxidation number is always -2, and there's 2 of them. So we can find this out by doing some algebra type stuff by doing this. And we know the overall charge is 0. So 2 times -2 plus C is going to equal 0. Now what does C oxidate equal? +4. So then we know that this is +4 and this is -2 and there's 2 of them. So combined that equals 0. Now we're going to look at an ion, which is permanganate, which has an overall charge of -1. So again, we know that oxygen's charge is -2 and there's 4 of them. So 4 times -2 plus manganese's charge is going to equal -1 this time, not 0. So Mn oxidation state plus -8 is going to equal -1. So what plus -8 equals -1? Plus 7.
So here's a classic redox problem. We're going to figure out which one of these is being oxidized, which element's being oxidized, and which element is being reduced. Okay, so we look over here. Calcium solid is in its elemental state. That means its oxidation number will be 0. HCl, we know that chlorine is going to dissociate. It's an aqueous solution. It's going to dissociate. So that means the oxidation number of hydrogen is going to be +1, and the oxidation number of chlorine is going to be -1. And then moving on to the product side of the reaction. So we can see right now how this is also going to be an aqueous solution, and it's going to dissociate into ions. So that means in order to get the overall charge of 0, the calcium is going to have a oxidation number of 2 plus, and chlorine is going to have an oxidation number of -1, and it's going to be 2 of them, so that's going to come up to 0. And then hydrogen, H2 gas, is in its elemental state, so its oxidation number will be 0. So we can clearly see right over here, calcium is going from a oxidation number of 0 to 2. And we can also see that hydrogen is going from an oxidation number of 1 to 0. That means calcium is losing electrons, so it is being oxidized. Calcium is oxidized, and hydrogen is reduced.
All right, so this next example is a problem where we need to balance the redox reaction, which is a little bit more complicated. So we already looked before, and right now the first thing we need to do is assign all the oxidation numbers. So this is permanganate, and we already saw that this is +7 and that would be -2 because it's oxygen. Now for this ion, we can figure it out. So this is +3, and that's -2 against oxygen. So then now, on this side of the reaction, we see that this monatomic ion has a charge 2+, and so by our rules, we know that this is +2. And then carbon dioxide we also already looked at, which is +4 and -2. Okay, so the first step is to divide this into oxidation and reduction half reactions. So we can tell by our oxidation numbers that carbon is being oxidized because it's losing electrons, so we can see it's becoming more positive. Manganese is being reduced because it's gaining electrons. It's becoming more negative, going from +7 to +2. So we divide it into these two half reactions. And the first thing we want to do is balance the elements besides oxygen and hydrogen. So first we can see that there are 2 carbons on this side, but only 1 on this side. So we need to add a 2 here to balance that. Next, we want to balance the oxygen atoms by adding water if needed. In this case, it's not needed, so we're okay. And then we need to balance it based on hydrogen ions next, and there are no hydrogen, so we don't need to do that. Now we need to balance the charges by adding electrons as needed. So we can see that there are 2 more electrons on this side because of this charge than this side. So we need to add 2E-. Now we need to okay, stop. All right, so next we're going to do the same thing with the manganese half side of the reaction. So first we need to balance the elements other than O and H, and the manganese is already balanced 1 to 1, so that's fine. Next we need to balance the oxygen atoms by adding water as needed. So as we can see, there are 4 oxygen atoms on this side, but not on this side. So we need to add 4 H2O to that side. Next we need to balance the hydrogen atoms, and we can see now we've added 8 to this side, so we need to add 8 hydrogen atoms. So after that, we need to balance the charge by adding electrons as needed. So we already looked at, based on the oxidation numbers up here, we know that we need to add 5 up here. And also, yeah. All right, so now that we've taken care of both of the half reactions, we need to multiply each one by an integer as needed to make sure that there are the same number of electrons on each side, because they should be even so that they can cancel out. So we can tell by this is 5 and this is 2, so we multiply this whole thing by 5 and this whole thing by 2. So now after we do that, we're going to write out the whole thing. Now we have the whole final equation that's been balanced. We added the 2 half reactions that were balanced and then multiplied back together. And so now this is the whole thing. And we can notice that we can cross out the 10 electrons that are present on both sides because they just cancel out. And so that is how you balance a redox problem. All right, so here are the steps that we used in the last problem to balance the redox reaction. So number 1, divide into oxidation and reduction half reaction. All right, so the next step is to balance each half reaction. And so the sub-steps of that is balance elements other than O and H, balance O atoms by adding H2O, balance H atoms by adding H+, and balance the charge by adding electrons. All of those, the last 3 steps, are only as needed. All right, multiply each half reaction to make the number of electrons on each side equal. This way we ensure that the electrons lost on one side are the same as the ones gained on the other. Lastly, check to make sure that the atoms and charges are balanced on both sides. Number 4, add the half reactions back together and simplify by canceling out species that appear on both sides.